So today we're going to talk about perpendicular lines, which is a little bit different, but that's okay. Lots of interesting stuff going on here. First thing we want to do is talk about what makes a perpendicular line and what's important and how this is related to distance formula, because you knew distance formula was going to show its face in here somewhere. So the first question we have today is find the distance from point A to line BD. And pretty reasonable question, well, how far apart is a point on a line? The question becomes, how do we measure that? I mean, do I take from A to B? Do I take from A to C? Do I take from A to D? What do I choose? I mean, point A is right here, but do I measure the distance here or to here, or which one do I choose? So that's going to take a little bit of figuring out which one do I choose. And there's actually a correct answer. Okay, oops, got to remember, new smart board here. There we go. What we're going to choose is based on the fact we're using the unit on perpendicular lines, we're going to choose the perpendicular distance. Why? Because the shortest distance. If I take any one of these other points, I could actually find, and swing it around, I could actually probably find a second point the same distance away. Or in this case, if we're going 2, okay, there's a second point there that's equally distant from A and still is on line BD. So what we have to do is we have to, in order to find the distance between a point and a line, find the perpendicular distance. That will be the shortest distance. And of course, find the distance once we determine that my 2 points are A, and C. I'm just going to use my distance formula, which we've used many times. Okay, we're going to plug in our points, our -3 and 3 for the x and the y, and 1 and -1 for the x and y here. And we're going to do our math. -3 minus 1 is -4 squared. 3 minus -1 is 3 plus 1. That's 4 squared. And squaring them both, I get a 16 and a 16. Remembering squaring a negative gives me a positive. That's the square root of 32, which of course, when we simplify, 32 is 16 times 2, or 4 root 2. And there's my distance. My distance is 4 root 2 units. And again, that's because it is the perpendicular distance. That's what we're looking for. So let's look at our theorems about perpendicular lines. First off, the perpendicular pair theorem, pretty obvious. If two lines intersect to form a pair of congruent angles, the lines are perpendicular. In other words, I have two lines, G and H, intersecting here. They are forming congruent angles. Angle 1 and angle 2 are congruent to each other. Now, they're a linear pair. That means they must add up to 180. They're congruent. It must mean they're both 90, which means these angles are right angles, which means that those are perpendicular lines. Fairly obvious. Perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, it's perpendicular to the other line as well. Again, given that H and K here are parallel, okay, we're given they're parallel, I'm given J is perpendicular to 1, it's not a big leap to use corresponding angles. Well, if this angle right here, we call that angle 1, angle 2 down here would be the corresponding angle. We know since the lines are parallel, the angles must be congruent. Therefore, if a line is perpendicular to one pair of parallel lines in a plane, it is also perpendicular to the other one in the same plane. And finally, perpendicular transversal theorem. If two lines are perpendicular to the same line, then they must be parallel. So if M and N are both perpendicular to P here, M and N are both perpendicular to P, they must be parallel lines. And again, not a big leap because obviously these are corresponding angles right here and right here. And if corresponding angles are congruent, the lines must be perpendicular. We already know that. Okay, that's already a pretty clear thing. So what I'm going to do is I'm going to move around some right angle measurements, and you're going to tell me which lines, if any, must be parallel based on the statement. We'll do our first one together. I'm going to put a right angle here, and I'm going to clone that, I think, because I'm going to put another right angle right there. So if that's the case, what are the parallel lines? Now, we do have to be a little careful, and having a highlighter in your hand can really be useful at this point. So what we'll do is we're going to highlight the perpendicular lines there and there. Now, anything that's not highlighted is kind of out of the equation at this point. We aren't going to deal with those things. So Q is not a line we're dealing with at this point. Not at all. Nor are we dealing with P. We're only dealing with S, R, and P. And when I look at it and say, what are the parallel lines, it becomes very obvious that R is parallel to P. Whoops, don't want a highlighter. Let's try this. R is parallel to P, because both are perpendicular to S. So that's kind of the way that we do this, okay? Not too tough. Let's try again. This time I'm going to have you do it. Answer which lines are parallel based on the information I give you. So I'm going to say there's a right angle and there's a right angle right there. All right, now you tell me which two lines are parallel. Hopefully you went ahead and did that, and what you saw when you highlighted is there's that, and I got S and T, and sure enough, they're both parallel. Okay, so S is parallel to T. Let's take a look at another one. Let's try again. This time, I'm going to go like this. Now which lines are parallel? Well, again, we highlight, say, all right, I have T and P here, and this deals with S and R. Now, my problem is I've got what looks like a bunch of parallel lines here, but I don't have any two lines perpendicular to the same line. S is parallel to R, T is perpendicular, S is parallel, S is perpendicular to R, T is perpendicular to P, but never to the same line. So if I were to ask you what lines must be parallel here, the correct answer would be none. There are no parallel lines in this picture, given the information that we see here. I cannot make that conclusion. So we got to watch that. So one more for you here today. I'm going to give you, let's do this, right there. And again, you tell me which lines are parallel based on the picture you see. All right, another slide for us. Again, just kind of a real world type problem. It says, determine which lines, if any, must be parallel in this diagram. It's a little difficult to see. We're going to see things like this, but let's note we have a right angle there, we have a right angle here, and we have a right angle here. So this right angle gives me these lines, and very quickly we get, oh, these two lines must be parallel, they're both perpendicular. P and Q must be parallel, both perpendicular to S. But I also get this, and I notice that T and S are both perpendicular to Q, so T and S must also be parallel. I don't know anything about U. There are no right angles on U, so I can't make that conclusion. So the conclusion, if I were to write it out, would be S parallel to T. I meant to get a red pen there. And the other one was P parallel to Q. Okay, and if you want a reason why, again, S is parallel to T because both are perpendicular to, and notice the symbol for perpendicular, the upside down T. Looks like a right angle, looks like perpendicular lines. S parallel to T because they're both perpendicular to Q, and P perpendicular to Q because both are perpendicular to S. Kind of a very similar thing here, but ask a little different question. Is B parallel to A? Explain your reasoning. Well, let's find B and A. So B is right there. It's not showing up so good in the highlighting, but A is right there. And I do notice they are both perpendicular to line D. So my answer, of course, would be yes. Both lines perpendicular to D. Now the next question is a little more interesting. Is B perpendicular to C? Okay. Is B perpendicular to C? Let's find. I don't have a right angle mark in there with B and C. Okay, B is right here. C is right here. Okay. I don't know if that's right angle or not, but can I make the conclusion? I do know that B is parallel to A. We got that right here. We explained that already. B is parallel to A. And A is perpendicular to C. Therefore, B must also be perpendicular to C. That was one of our theorems. Okay? In a plane, if a transversal is perpendicular to one of two parallel lines, it's perpendicular to the other line. Right there. So yes. And again, because B is parallel to A, and A is perpendicular to C, so B must also be perpendicular to C. These are the types of problems you'll see in the assignment. And again, perpendicular isn't a totally new concept for you, but the way we look at it here in geometry is a little different. We will see some coordinate plane work as well, so be prepared for that. All right, see you in class.